Today, we're diving into a paper that's, well, it's a huge leap forward. We're talking about changing how AI finds information, transforming it from a simple, little helper into a real-deal research agent.
You know that feeling, right? You ask your AI assistant a really tough question. You know it's smart, you know the brain power is there, but the answer it spits back is just kind of meh. It feels like something's holding it back.
And the reason why is actually pretty simple when you think about it. We've built these AI models with these incredible reasoning engines, but we've been forcing them to follow a really strict, simple recipe for finding information. It's like having a genius librarian who's only allowed to read the single page you put right in front of their nose.
This is the old way of doing things. It's called naive RAG. Basically, the AI gets a pre-selected bunch of text, these little chunks of info, and the instruction is simple. You can only use what's right here to answer the question. So, the AI is just a passive tool. It's not actively involved in the search at all.
So that brings us to the core question of this whole paper. What if we just untied its hands? What happens if we stop spoon-feeding it information and let it go find the ingredients for itself?
And that is the big shift we're talking about, moving from a passive tool to an autonomous agent. Think of it like this. The old way is like a novice cook who has to follow a recipe exactly. The new way, that's a master chef who can roam the whole pantry, look at all the ingredients, and decide for themselves how to create the perfect dish.
Okay, so how do we actually turn our AI into that master chef? Well, this research lays out a path. It's all about empowering the AI to become a true agent. Let's dig into how they do it.
Introducing Agent RAG, or ARAG for short. Now, this isn't just another small tweak. It's a whole new framework. It doesn't just hand the AI information. No, it gives it a toolkit, and this is the really important part, the autonomy to decide for itself how to find the answers.
So here's a look at how it works in practice. The agent gets a question, and instead of just being handed a blob of text, it starts thinking. It has this set of tools, and it uses them to explore the knowledge base at different levels of detail, kind of like zooming in and out, from the big picture all the way down to the nitty-gritty.
So what's actually in this toolkit? Well, it's got three main things. First up is a classic keyword search, for finding precise terms just like Google. Then it's got semantic search, which is way more powerful. It's for exploring related ideas and concepts, not just exact words. And finally, there's chunk read. Once it's zeroed in on something promising, this lets it dive in and read the full details. All right, to really get why ARAG is such a big deal, it helps to see what it's up against. Let's look at a couple of the other ways people have tried to solve this problem.
First, you've got something called Graph RAG, and it's pretty clever. It builds this complex map of information, a knowledge graph, showing how everything's connected. But here's the catch. The AI is still just a passenger. It has to follow a fixed, rigid algorithm to get around that map. It can't explore on its own.
Then there's Workflow RAG. The best way to think about this one is like an assembly line. The AI is forced to follow a super strict step-by-step checklist. If, then, you get the idea. It works okay for simple stuff, but if a question needs a creative approach, forget it. There's zero flexibility.
And that brings us right back to Agentic RAG. And you can see now how different it is. Here, the AI is actually in the driver's seat. It's got the keys. It has all these tools, and it gets to choose its own path, changing its strategy on the fly depending on what it discovers. It's dynamic. So the paper lays out what it really means for an AI to be an agent. There are three core principles. One, it has to have an autonomous strategy. It decides what to do. It's not just following orders. Two, it uses iterative execution. It tries something, learns, and tries again. And three, it has interleaved tool use. It can switch between its tools in any order that makes sense. And guess what? Out of all the methods, only ARG actually checks all three boxes. Okay, so the theory sounds amazing, right? But here's the million-dollar question. Does giving the AI all this freedom actually work in the real world? I mean, this is it. Does untying the AI's hands and giving it a fancy toolkit actually lead to better answers? Or does it just get confused and go off the rails? Let's find out.
Well, the data's in, and the answer is a resounding yes. Just look at these results. This chart shows that even a basic version of the agentic approach, they call it naive ARG, consistently crushes the old methods. We're talking across multiple really complex question-answering datasets. This is pretty much definitive proof that letting the AI be autonomous works.
But wait, it gets even better. Not only is ARG smarter, it's also way more efficient.
Check out this table. It's comparing how many tokens. Think of that as how much text each system has to read to get an answer. And look, ARG reads way less. Why? Because it's not just randomly grabbing info. It's being smart about what it looks at. It's like a great researcher who doesn't read the whole library. They just know exactly which book to pull off the shelf.
Okay, let's just pause for a second. This is a pretty big deal. So what does this shift actually mean for the future of how we and our AI assistants find information?
And this brings us to the final and maybe the most fascinating insight from this whole paper. ARIG is so effective, it's so good at finding the right information, that it basically solves the retrieval part of the problem. But in fixing that, it actually exposes a totally new problem, a new bottleneck.
Just look at this. This chart breaks down why ARG fails when it does. And it's almost never because it couldn't find the right stuff. A whopping 82% of the time, the failure is a reasoning chain error. What does that mean? It means the AI found all the right puzzle pieces, but then it put them together wrong. It made a mistake in its own thinking.
And this quote from the paper just nails it. The bottleneck has shifted from cannot find documents to found documents but reasoned incorrectly. How wild is that? We've solved the problem of finding information so well that now the real challenge is the AI's ability to think about it correctly.
So that leaves us with one heck of a final thought. We've basically succeeded in building an AI that can find information like a top-tier researcher. So the next great challenge, the next frontier, is crystal clear. Now that it can find like a researcher, how do we teach it to think like one?